Hello, I'm Willing reporting for the Fun Robotics Network. I'm here at the North Brisbane Regional with Team 24089, the Iron Lions. They were the Finalists Alliance partner. Learn about their color profiling, finite state machine, and their autonomous op modes on Behind the Bot.
This video on fun is brought to you by viewers like you and also in partnership with the following. The new Robot system by AnyMark can reduce complexity and enable robust builds. Parts aligned to a common 1/2 inch grid, simplifying construction and allowing alignment of both structure and motion components. Robots enables teams to always have the parts they need to complete a build. Head on over to anymark.com/robots to learn more and order today.
So would you like to explain how that works?
Alright, so first I'll talk about the intake. So as mentioned up there, we're using color profiling, which means we're actually scanning the samples as they go through and deciding whether to spit them out the other side or to keep them based on their color. So I'll just grab the controller and give you a demonstration. First one. Yeah. There we go. So, alright, Rowan, can you pass me the samples? So in this case, if I hold the blue one, the red one, it'll spit it straight out, making it harder for the other team to get it. When it gets a blue one, it will accept it, ready for the transfer. And it can just spit it out, ready to transfer like that. So all those actions are predetermined by our finite state machine, which essentially stores the way the robot should be and then moves the motors into those positions. And so all we need to do to move the robot is change the state, and it will act according to plan, which makes sure that it doesn't get stuck. And it also allows us to use it in autonomous and teleop as well. So do you want to talk about autonomous now, Marley?
For sure. So our autonomous this year has been quite the journey, but I've actually ended up deciding on Pedro pathing. Pedro pathing is a autonomous pathing library that uses Bezier curves to make really energy and time efficient paths. And so this robot is actually able to use Pedro pathing to do super efficient autonomous op modes using both movement and robot actions at the same time to score as many points as possible in the autonomous.
So how does your transfer work and how do you deliver it?
Alright, cool. So because we've got an intake with 2 wheels on each side, we're able to reverse or put samples forwards in both directions. So we're able to spit them out each direction, including into our outtake. So for this to occur, we actually went through several design iterations. At first we had a top roller, and when that didn't work as well as we anticipated, we moved to side rollers and eventually settled on this design with 2 wheels. As for the transfer, we had originally a bucket for the outtake. The bucket shook around a lot, sometimes dropped it, so we actually ended up switching to this claw. So it uses custom silicon molds to grip the sample really well to make sure that it does not drop it whatsoever. And so that can just hold it as we drive around and eventually flip it up into the basket.
Thank you very much. So how do you bring these your delivery up into those baskets?
Okay, so from the claw here, we actually have a set of linear slides that come all the way up to the highest basket. So this claw here is actually able to come over that top of that basket and drop it in. So if you want to do an example outtake, these slides come all the way up and it'll come up and drop it in the top basket there. And that's able to do that incredibly consistently so that no matter how the transfer ends with the sample in the outtake claw, it will always get into that top basket. A notable thing here as well is this little latch here to make sure the robot stays together when it needs to, so that the intake cannot fly around and hence throw the robot off.
So why did you choose to go with the samples and not the specimens this year?
We made the executive decision to go for samples because we feel like we can much more consistently cycle samples at a much higher rate. While we may reconsider looking at specimens for nationals, we decided that for the sake of the design and programming overhead and the amount of points that we can get in the time we have, it was a better decision for us as a team to go for the samples.
And what type of improvements do you want to make, especially to this robot when going into nationals?
Cool, so the first thing we're looking at changing is this kind of arm system. So you can see it's based off of a chain drive, but it has a very high mechanical advantage, so it's not great. It's very slow going up. And the same goes for the way we're folding down our intake currently with 2 servos. It's very slow. So we're hoping to improve those, which will drastically improve our cycle times. And then maybe just making the outtake transfer system a little bit more consistent so that we can be absolutely sure we don't get stuck anywhere.
Thank you very much for sharing your robot, and congratulations again for being the Finalists Alliance partner. You've had an amazing time at this comp, so I can't wait to see what you guys do at the Australian Nationals. Good luck, and thank you very much.
This video on fun is brought to you by viewers like you and also in partnership with the following. The new Robotics system by AnyMark can reduce complexity and enable robust builds. Parts aligned to a common 1/2-inch grid, simplifying construction and allowing alignment of both structure and motion components. Robotics enables teams to always have the parts they need to complete a build. Head on over to anymark.com/robotics to learn more and order today. First Updates Now has become the Fun Robotics Network. Check us out at funroboticsnetwork.com and all the social links that you see above here. And check out some of our new merchandise options that are both fun and robotics related as well too, both on our website and right underneath this YouTube video.